All right, and I do believe we're going to have a few more people join us, but we'll go ahead and get started because I have a lot of information to share with you. So one more time, hi, my name is Janelle Ware, and I am the horticulture educator with Extension, serving Marathon and Wood counties. And tonight we are going to talk about soils. So we're going to talk about soils and soil texture and more. So let me go ahead and get my slide deck up and let me share my screen and we will get started. Okay, so this is, by the way, for anybody who doesn't know, this is session 3 of a 12 session series where I talk about all the different facets of gardening, all the things that are going to be important to know about. In this session, we are going to talk first about soil texture, and then we'll get into soil pH and nutrient availability, and what all that means. Then we will talk about the benefits of compost. And hopefully after I am done talking about the compost, apologize, I got more people joining us, exciting. So hopefully after I am all done talking about the benefits of compost, I will have you sold on it and you will, if not composting at your house, you will want to compost or you'll want to at least add some organic matter to your gardens. And then finally, I apologize. I'm just letting a bunch of people inside the room. Then after we've talked about the benefits of compost, we will talk about, well, how do we get started? Hopefully I've convinced you. And so how do you get started? What kind of materials can you compost? And then we'll finish up with the fertilizer basics and I'll just talk real briefly about soil tests. So just to kind of get us started, we got a big group today. So we're going to be using chat a bit as we get through this session. So why don't we just kind of check in? If you haven't already answered, go ahead and answer inside the chat. Do you compost? And if you do compost, how long have you been composting? So I had said earlier that I've been composting. I think it's been about 8 years. My main focus when I compost is taking care of my excess lawn waste. So go ahead, look for that chat, look for the chat box and go ahead and drop if you've been composting and if so, how long. So it looks like we got a couple of people that they haven't composted before. Um, and like I said, you can get the benefits of compost by not composting, but just getting your hands on composted materials too. So you can purchase those things at the store, or you might know somebody that's got some extra compost too. So let's see, we've got about 3 years of 5 years, give or take, another 5 years or so. So it looks like we got some new people to composting, but we've got some people who've got a little bit of experience too. All right, so awesome, and kind of pull that background knowledge and kind of get us ready and thinking about what we're going to talk about this evening. So let's jump right into soil texture. Apologize, bear with me for just a brief second. I'm just getting all of my little screens with the chat screen and the participants all set up. Okay, so ideal soil texture contains about 50% pore space and then 50% solid particles. So your soil, what I mean when I'm talking about that soil texture is it's the proportion of solid materials in the soil. So that's going to be sand, silt, and clay particles. And the sand, silt, and clay, that's going to be decided based off of based off of the parent material or the weathered rock that have eroded over time and became a very, very small particle. If it's got a lot of silica or the minerals that it will become, and the size of the particle is going to be based off of the type of mineral that it started off with. It's a lot to say there. Basically, what I want you to keep in mind is in an ideal soil, 50% is going to be pore space, and that pore space will have both air and water in it. So if we're looking right here, this space in between, all this little space in between these particles, that's our pore spaces. Now, well, I'll get into that in just a second. So the other piece of solid particles that are going to be in soil is organic material. Okay, so your organic material is going to only take up about, in an ideal soil, in a loamy soil, in a really, really nice, healthy soil, it'll be about 5% of the makeup. And then the rest of the solid particles is going to be about 45%. So 5% organic matter, 45% either sand, silt, and clay, and then the other half is going to be pore spaces. And ideally, those pore spaces will have some water and some air, split about 50-50. One thing I want you to keep in mind as we go through this graph, this slide, and the next two slides after this is this picture that I've created here. That's just to illustrate the concepts of the sand, the organic matter, and the silt, or the clay. I don't even have silt listed because I just thought it would be, for the purpose of what we're doing tonight, it might just be added clutter on there. So keep in mind that silt does exist too. The other thing too is this is not drawn to scale. So yes, the sand particles are going to be larger than the clay particles, but in truth, the sand particles are much, much, much larger than the clay particles. Okay, just want to make sure I said that. So let's talk about sandy soils. Sand and silt particles, like I just said, they're relatively large, and you'll notice they create very large pore spaces. And your large pore spaces are going to be more inclined to be filled with air rather than water. Okay, so let's think about that. If you've ever tried to garden in a location that had really sandy soil, or even just think about being at the beach, at the lake, water drains very, very quickly in those sandy soils. The other problem with sandy soils is because of these large pore spaces and the water just drains and the pore spaces fill up with air instead of water, your nutrients will leach off because of all that fast draining. Nutrients are less likely to stay in that space too. So in sandy soils, we struggle with soil moisture, and we also struggle with having enough nutrients for our plants to really grow and thrive. Just checking my notes real quick to see if there's anything else I wanted to talk about. And I did. I wanted to talk about how it feels. So if you have a sandy soil and you take a handful and you put it in your hand and you're rubbing it, you're going to notice a gritty texture. It's going to feel, it's going to feel like you'd expect it to. Very gritty, like sandpaper. Okay. And if you have a very, very sandy soil, if you take a handful of it and you put it, ball your fist and you open it up, it's just going to crumble right through. It's not going to hold its shape very well. Okay. Now, on the other hand, clay particles are very, very small. They're the smallest of those particles. And because of that, and also their shape, they're kind of shaped like a pancake. And so because of that, they have very, very small pore spaces in their soil. Those pore spaces tend to get filled with water instead of air. And so that's the reason why clay soils can be so heavy, and they can also be very difficult to drain. They don't drain very well. They stay soggy for long periods of time, as opposed to that sandy soil. That sandy soil, it drains really fast. It doesn't stay wet very long. When we're thinking about that texture of, how does that feel? How do I know by feeling it if this is a clay soil? You'll know it because it's going to feel sticky. If you rub it in your hands, you'll feel that sticky texture to it. And if you take a handful of it and you make a fist and you're with a clay in your hand, when you open your hand up, it's going to retain its shape. It's going to be a lump in the center of your hand, right? That's how you know that you've got a clay soil. So one thing I want to kind of throw out there for you, and you will hear me repeat this several times over the course of the session. One way to get around sandy soil is to add organic matter, compost. And the way that organic matter is going to help, so imagine we've got a bunch more of these little green pieces in here, that organic matter. What the organic matter does is it acts like a sponge, and it'll actually help retain some of that soil moisture. And with it, it'll help retain some nutrients too. In our clay soils, when we add more organic matter, what that actually does is it'll bind with some of those clay particles, and it'll actually form a slightly larger particle. And when when we have those larger particles, it's not ever going to act like sand. You're not going to have giant pore spaces in there, but it will help with the drainage. And so it'll help you so that way it doesn't drain, or it'll drain more quickly. I'm just checking my notes to make sure I covered everything that I wanted to. And I think we're there. Oh, one other thing to keep in mind. Remember how I said sandy soils don't retain nutrients very well? One benefit of your clay soil is your clay soil is really going to hang on to those nutrients. It's going to be less likely to have those nutrients leach. Okay, so go ahead and, or I'm sorry, let me back up for a second. So compacted soil is the enemy of the gardener, okay? And what I mean is when you lose those pore spaces, that 50% of the soil is supposed to be pore spaces. Well, if you go and you walk or you do anything inside on the ground, over time, those pore spaces are going to get scrunched. You're going to lose those pore spaces. And those pore spaces are so important. When you have compacted soils, it doesn't drain as well. So you run into all sorts of issues from not having good drainage. So you want to avoid compacted soils as much as possible. So I'm just curious, go ahead and drop it in the chat. What are your ideas for protecting your soil from compaction? Any thoughts? You can go ahead and put it right inside the chat. Raised beds that are small enough so I don't step inside. Paths in the garden. Nice job. Nice job, both of you. So yes, permanent paths and permanent beds. And we can kind of see that in this picture. So that's what I was going for when I picked this picture for this slide. Here you can see, so this is a community garden. I think this is a community garden in Rapids. And here you can see that they have permanent paths laid out for the gardeners. And I would take it even one step further. If this was my spot in a community garden, what I would have defined right away is where are my paths going to be? And I would mark them, and I would try my best over the entire garden season to stay in the path and not step inside that garden space, the garden bed space, right? So raised beds, same idea. If you have your bed and it's only 4 feet wide, then you should be able to reach about 2 feet on each side. So yeah, I love it. Any other thoughts? So I've got one that is very uh, good timing for right now. And it's don't rush in the spring. So if you start working really wet soil before it's had a chance to fully thaw and drain off from the winter freeze, if you get in there too early, you're going to end up adding to the compaction in your soil. So you want to wait until it's dry enough. And the way that you'll know if it's dry enough is go ahead and just get a handful of dirt, right? A handful full of that garden soil and give it a good squeeze. If water runs down the side of your fist and down your arm, your soil's too wet. Another thing is if you're working with tools inside the garden and your tools, the soil is sticking to your tools, the ground's still too wet. If you make a fist and you open it up and it crumbles, it can still kind of stick together a bit. But if it crumbles, then you know that it's dry enough and you can go ahead and get inside your garden. Okay, so that was soil texture. Now we're going to switch gears a little bit and we're going to talk about soil pH and nutrient availability. So if the soil pH is wrong by either being too high or too low, then the nutrients will not be available for the plant. So let's unpack that. What do I mean by that? Well, let's start off with what is soil pH. So it's simply a measure of how either acidic or how basic the soil is. Um, Different plants, well, first of all, different nutrients will be available to the plants at different pH levels. At really extremely high and extremely low pH levels, those nutrients will not be in a form. They actually kind of bind with other minerals, other elements. And so the pH has got to be just right for those minerals to be available. Now, also, different plants are going to have optimum pH for themselves. And I'm not really thinking on individuals, I'm thinking of species level. Okay. So, some examples rhododendrons and azaleas, they like a lower pH. Asparagus can tolerate pretty high pH. It can tolerate up to 8.0. Um, Blueberries, and let me just go to this page. So here's our pH scale, and it goes from 0 to 14. Those lower numbers, that's where you're more acidic, up towards 14, that's where we get to be more alkaline. And right in the center at 7 is neutral. Okay, most of our garden soils tend to be in Wisconsin, tend to be between a 6 and a 7. But you can have extremes. You can have much lower acidity, or even some areas that are actually rather alkaline. I know as you get more towards Lake Michigan, the soils tend to be a little bit more alkaline over there. So here we've got a blueberry plant, and this blueberry plant is growing in neutral soil. It's probably like 6.8, something like that, right? And you'll notice he doesn't look very healthy. He's not happy. What you can see here is we've got some discoloration. The leaves are actually turning more yellow over time, and the real deep, rich green is just in the veins. What's happening is this plant is suffering from iron deficiency. So the thing is, there's plenty of iron in that soil. The soil's not deficient. It's that the blueberry wants to grow in 4.5 to 5.5 pH. Since we're growing it closer to a 7 pH, that iron that's plentiful, it's nearby, the plant can't make use of it because the soil pH is off. Okay. So one way I like to think about pH is I think of it as pretend that pretend that this is a garden hose, okay? Pretend that pH itself is the garden hose, all right? And the like water would normally go through a garden hose. Instead, we've got plant nutrients flowing through this garden hose, okay? If the pH is correct, our garden hose is huge. It's nice and big, and lots of nutrients can easily flow through our hose. But if our nutrient or if our pH is wrong, that garden hose becomes very, very small, and we don't have as many nutrients able to flow to the plant. And eventually, depending on how bad the pH is and what nutrients are becoming deficient, we might end up with a dead plant altogether. So not only will it not thrive, but it just simply won't even live. Um, and so that's what will eventually happen to this blueberry plant. Okay, so that was pH and nutrient availability. If you want to dig deeper into the chemistry, I believe it's the very first handout or the very first link under the resources on your handout. I linked to a North Carolina extension manual, and that but I linked to the chapter on soils, and it's got a nice description of what's actually happening with the H positive ions and the OH ions. You can dig into that. More information is definitely going to complement your understanding, but big picture, what you absolutely need to know about nutrient availability is just you got to have that pH correct. Otherwise, the plant's not going to be able to get those nutrients. Lucky for us, like I said, vegetable plants tend to be in this, vegetable plants tend to be in this between 6 and 7 range. And that's about where most of our garden soils are going to be too. Okay, so now we're going to talk about compost. And I'm going to start off by giving a hopefully good argument for the benefits of composting. So, probably the biggest one, if you don't remember the rest, the biggest one I would like for you to remember is that compost improves sandy soils and it improves clay soils. With sandy soils, adding that organic matter is going to help those soils retain nutrients and also moisture, so water. When it comes to your clay soils, it's going to improve that drainage. And those are like the main problems for each of those types of soils. But that's not all. So adding compost to the soil also increases your micro and your macroorganism activity. So we think about a soil. Well, I bet typically people don't think of biodiversity when they think about their soils. When we say biodiversity, I think people tend to think of places like the Amazon rainforest because there's lots and lots of different types of plants and animals. But in a really healthy soil, you're going to have a nice diverse ecology happening in there too. Adding compost is, oh, let me back up for a little bit. So, why do we want this diverse ecology? Why do I want lots and lots of bacteria in my soil? Well, the bacteria is, first of all, they help with the decomposition. So let's talk about the lawn, right? If you have any leaves or any grass pieces that land inside the lawn, over time, they are going to even the pieces like think of like a mulching lawnmower that's going to decompose over time. Um, and these organisms are going to be responsible for that decomposition. These organisms, when they're basically what they're doing is they're eating both in our compost pile and just out in nature. They are eating the waste that we're putting inside the compost bin, and they release it as a product of their eating. Basically, what I'm saying is that they poop out nutrients. Okay. Um, And if not all microorganisms eat the same thing, and not all of them release the same nutrients in their waste material. Okay. And so we want a nice wide diversity of different types of organisms to be able to convert uh, waste materials into nitrogen, phosphorus, and potassium in a form that the plants will be able to use too. That's the big benefit of microorganisms. But not only that, you've got your macroorganisms. So it's going to be things like grubs and earthworms, things like that. The benefit that they bring to the soil is just by crawling around or squirming around inside the soil, they actually improve aeration. So they add some pore spaces to your soil. But the other benefit too is underneath your soil, you've got your bedrock, right? And the bedrock is made out of all sorts of different types of minerals. These macroorganisms, our grubs and our earthworms, are actually pulling some of those minerals from the subsoil all the way up to the surface. So, and those minerals are not all of them, but many of those minerals are going to be important for our plants to our plants' health. Adding compost can also increase disease resistance. So sometimes when you add, not all diseases and not all insects, but compost can help with some diseases and some insects, especially soil-borne diseases that soil-borne fungal diseases that have a tendency to either splash back up onto our plants for a foliar disease. So right now I'm thinking about those tomatoes with septoria or maybe early blight, but it'll also help out with certain types of nematodes. So nematodes are very, very small microscopic organisms. This is actually, I think it's an electron microscope image of a nematode. So they kind of remind me of the sand monsters from Dune, if you read or saw that book or saw that movie. Um, and some types of nematodes can cause really bad diseases, like what we've got here on these carrots. And then finally, compost acts like a buffer inside the soil. So it's going to help protect from extremes in pH. It will also help fix heavy metals in the soil. So if you live in a more urban environment, like me, so I live in Stevens Point, not the largest urban area, but my house was built in 1931. So it's an older home. Um, and by soil, probably I haven't had it tested for heavy metals, but I wouldn't be surprised if close to the house I had maybe higher levels of lead because of lead, traditionally lead paints were used, things like that. So it has a higher capacity to fix those heavy metals and then neutralize toxins in the soil. It'll also help with salt concentration. So here I'm not really talking so much about table salt. I'm thinking more about fertilizer salts. So salt in the way that chemists think of that word. And where you would probably use it, or where the salts would affect your garden plants the most would be fertilizers. Perhaps if, say, you've got a garden that is by the boulevard, so over by your sidewalk, and you put down salt for sidewalk salt to de-ice in the wintertime, that'll have a buildup of these types of salts as well. It also moderates temperature. And it does this in two really great ways. So if you put a nice thick layer of compost down in, say, the fall or really, really, really early spring, that compost is going to be really dark in color. So it absorbs lots of light and it absorbs that heat from the light. That's going to help with that spring thaw. But in the summertime, even though it's warm or even though it's dark in color, it'll actually protect the soil underneath it. So if you put down a nice thick, like a mulch layer of compost on top of your garden bed, excuse me, it will and because it helps with retaining moisture, it will help keep that soil underneath a little bit cooler. All right, folks, it's time for a pop quiz. I'm going to be quiet for a couple of moments and I will let you read through each of these answers. Go ahead when you think you know what the answer is, drop it inside the chat. You don't have to type the whole thing out, just type the number, okay? So I'm going to be quiet for a moment, probably about 30 seconds or so, maybe a minute, and I'll let you all put the answer that you think is correct inside the chat, and then we'll talk. All right, so woo, we got some votes for 10. Let's see, is that 1, 2, 3, 4, 5, 6. So we got 6 votes for 10. Don't remember talking about number 4. Oh, you're right, I didn't mention that one. We'll talk about it in a second. I'm going to give everybody another maybe 10 seconds or so. Got another vote for 10. 10's we're feeling 10. All right. Got another vote for 10. Okay, let's see. Let's see what is the answer. It was 10. You're right. So let's back up for a second, just kind of go through these one more time. So these first ones are actually kind of talking about that soil texture. So it improves the soil texture, water retention, soil aeration. Those all kind of connect with that texture. Improves resistance to erosion. Yeah, you know what? I think Katie mentioned that one. And yeah, I hadn't mentioned that. I think I must have skipped over it when I was going through these, but it will improve. It improves the resistance to erosion, adds and stores nutrients. We talked about that and how important that is inside our sandy soils. Discourages certain diseases, especially those nematoids. Improves the ability to absorb rapid changes in pH, neutralizes certain toxins, and keeps the soil temperature stable. I've got one more for you that I didn't put on here, and it's so if you've got a really heavy clay soil and you want to plant seeds, you want to direct sow seeds inside of it. So let's pick on carrots because carrot seeds are so tiny and the baby plants that start off are just very, very tiny little plants. A heavy clay soil will form a bit of a crust, a thick crust on the top, and it will make that crust will make it difficult for a seed to germinate. And even if it germinates, it'll make it very, very difficult for a seed to be able to break through that crust and grow, right? So picking on those carrots, sometimes people struggle with carrots because they can't get them to germinate inside a heavy clay soil. Adding some compost to that soil is going to help with uh, that crusting action that happens at the top. And it'll actually provide a better seed bed for you. All right. So the quality of finished compost depends on the variety and balance of materials. Now, full disclosure, I had a great conversation with somebody earlier today who was kind of going through the handouts actually from this program. And he mentioned that in some of the extension materials, they actually suggest a mix of 2 parts brown to 1 part green, where I've got 3 parts brown to 1 part green, okay? So actually, well, I'll go ahead and finish my thought. If you go, you can definitely get where I got the 3 parts brown, and it'll be one of the links in the resources for you on the handout. It's a master composter self-study, and in it, they suggested the 3-to-1 ratio. That's where I was pulling that from. But after talking to Jim today and like realizing that the more recent publications are suggesting that you go with 2-to-1 rather than 3-to-1. And I'm thinking it's so that way it'll actually decompose a little bit faster. So if you go with a 3-to-1, you can go with a 3-to-1 or you can go with a 2-to-1. Either way, your compost is going to happen. A 3-to-1 might happen a little bit more slowly. So just something to kind of keep in mind. So the variety of, let me back up for a second. So the quality of your finished compost is going to depend on the variety of the materials that you add and that balance of materials, okay? So the variety of the materials is actually going to increase the types of microorganisms that are hanging out in our compost bin. And like I mentioned earlier, you want a wider variety of different types of organisms because they are going to release a wider variety of nutrients for your plants inside your compost. Okay. So let's say that I am super into eating broccoli and my compost is just autumn leaves and broccoli stalks. I'm going to have a very limited types of nutrients that my compost is going to give me in the end. But if I've got shredded newspaper and autumn leaves and I'm trying to think of something else that would be like that. And maybe some newsprint. And I've got my broccoli stalks, and I've got some apple pumice, and I've got maybe some yard trimmings. I put my grass clippings. That nice wide variety of different types of things is going to give me lots and lots of different types. It's going to encourage lots of different types of organisms to come hang out in my compost bin. And in return, they're going to leave me a much wider variety of nutrients. One thing I want to keep in mind as I am talking this evening, I'm going to use the term organic when I meet tonight when I'm talking about organic, or I use that term, I just mean that it's something that was derived from a living organism. That's all. I don't mean in terms of how we think of like certified organic produce. Not that, not that at all. Just that I'm just talking about products that are left over from living organisms. Um, Okay, so I mentioned that ratio. We want either 3 parts brown or 2 parts brown to 1 part green. Okay, and what do I mean by that? How do I know if something is green versus if something is brown? Well, you can think of your green materials. Those are going to be very rich in nitrogen. Um, but the part that helps me is I think about nitrogen-rich materials as being juicy, okay? So really kind of get that image in mind that it's your juicier type of things, things that are really fresh, right? So, oh, and the materials that are animal byproducts, so things like manure. Manure is a great thing to add to your compost. Feathers, different types of meals like kelp meal, or I'm sorry, not kelp meal, but different types of meals like maybe a blood meal or a bone meal. Those are all um, rich in nitrogen. Your drier Yes, nitrogen. Your drier materials, your woodier materials, those are going to be your browns, okay? And they tend to have a higher carbon content, all right? Now, keep in mind, I'm using these terms greens and browns, but don't rely on the color, okay? 'Cause sometimes things can be the color brown, but they truly are rich in nitrogen. They land in the greens category, even if their color visually, they look brown. Okay, so now that I've given you a little bit of background, we're going to play a game called Is It Brown or Is It Green? All right, so go ahead and just drop it in the chat, green or brown. We're going to start off with veggie scraps. What do you think? Are veggie scraps going to be a green or a brown? And we got some votes for green right away, right out of the gate. Green, green. Oh, we got one vote for brown. One vote for brown. We got some votes for green. Let's give her a try. Let's see. It's a green. It's a green. Yeah, so think about those veggie scraps. Think about, like I keep picking on broccoli. I do love broccoli, and I do add a lot of broccoli stalks to my compost bin. You think about that broccoli, it's going, if I'm or the broccoli stalk, if I'm cutting that off, it's probably going to be pretty fresh, right? So that's one way to think about it. Let's try another one. How about manure? Is manure going to be a green or a brown? Let's see, we got 2 votes for green, 3 votes green, another green. Yeah, manure is a green. Manure can become a brown though if you let it sit for like 2 or 3 years. So over time, as it becomes less juicy, it will have less nitrogen. That nitrogen carbon balance will shift and it won't be so high in nitrogen. It'll actually get higher in the carbon. How about shredded newspaper? Green or brown? I got 2 votes for brown, another brown. Lots of browns. Let's take a look. Yeah, it's a brown. Coffee grounds. Ooh, this one could be tricky. What do we think? Green, nitrogen rich, or brown, carbon rich? So, and I lost track. I think we may have some greens and browns here. Yeah, we've got greens and browns. Oh, this is a tricky one. Yeah, so coffee grounds are going to be really rich in nitrogen. So what I think about is really when I think about coffee grounds and how the kind of reason in my mind why I mean it's because it's high in nitrogen, but the thing that kind of makes me kind of think about it is I think about the bean seeds, right? The coffee beans, and so it's just kind of ground up. Well, that is what it is. It's ground up seeds, right? And so that's where we get that really freshness and all of that nitrogen that's in it. Last one, autumn leaves. What do we think? Is that going to be a green or a brown? We got, I think, 1 green and I think 3 browns. Autumn leaves. Yep, autumn leaves are going to be carbon rich in the browns category. Now, let's say that let's say It's the middle of summer. It's July, and we have a ferocious storm come through, and it takes out some of my limbs on my trees, right? And so I'm going to add some of this yard waste to my compost bin. Not not the branches. I'm not going to add anything woody because that's going to take forever for it to decompose. But I'm going to take those green leaves and add them to my compost bin. If the leaves are green, then they would be more of in the nitrogen or in the greens category because they're so fresh. Our autumn leaves they're dry. They've lost a lot of their moisture content, and so that's why they're higher in that carbon. All right, so these materials are yes, but you're going to want to take some precautions. So first we've got cardboard and corn cobs. You can use those. Those are perfectly fine to add to your compost bin, but just be aware that they take forever to decompose. So really chop them up in the smallest particle size that you can, and then add something that's going to be rich in nitrogen. Add a lot of either greens, so like your vegetable scraps or your green lawn waste, or you could do something like add some blood meal because that's going to be high in nitrogen too. This next picture I've got down in the bottom here is apple pumice. So that's what's left over when you use an apple press. It's going to be your peels, your seeds, and the core, right? That is, you can definitely use it inside of your compost, but you're going to want to number one, be aware that it's got a lot of moisture in it, but also because of its shape and just the nature of apple skins, there's a really good chance that you could end up with compaction. And compaction, just like it's an enemy of the gardener in the soil, it's an enemy of the gardener in the compost bin. I mean, if you think about your compost bin, what are you doing? Like, what is the name of the game here? It's decomposition, right? And so for active decomposition to happen, at least in our compost bin, we need air. We need aerobic decomposition to happen. And if the apple skins all pile up and kind of seal it in and cause compaction, you're not going to have that oxygen or the carbon dioxide flowing inside of your compost bin, and your bacteria. Those, I mean, they're our soldiers. They're the ones that are doing all of the work inside the compost bin. If they don't have air, they're going to die off, and then you're going to have anaerobic decomposition to kick in. If anaerobic decomposition kicks in, it's going to be a much, much slower process. So we want to avoid that. So does that mean you can't use apple skins? You can't use an apple pumice? No, not at all. You can totally use it. Just be mindful when you add it. Make sure that you're adding it in with layers. And you may want to, so that way you're not getting that compaction, then you may want to mix in, this might be a great time to add some of those autumn leaves, or maybe some shredded newspaper in there just to help even out that decomposition. The last picture I've got is sawdust, and sawdust is slow to decompose. So be aware of that. But it could actually be super helpful if, let's say, that the neighborhood raccoon keeps digging into your compost bin. Well, next time that you're adding some fresh waste to your compost pile, sprinkle on the very top, sprinkle a nice layer, not too thick, but a nice layer of compost or of sawdust that will help with the smells, and hopefully it will make it so that way your compost pile is not attracting uh, wildlife like raccoons and stuff. So the previous ones were yes, but with caution. These are flat out no. Do not add these materials to your compost pile. So first picture, cat litter. In fact, you don't want to add any feces that is from an omnivore. Herbivores are fine. So you can add uh, rabbit feces all day, cows, um, horses, those are all fine. But you don't want to add cat feces, dog feces, nothing like that. No omnivores. And the reason why is that it might have some pathogens that are going to be harmful to human health. And then the other piece with the cat litter is the cat litter itself may contain chemicals that are harmful to your soil. Next, we've got those charcoal briquettes. Charcoal briquettes contain sulfur oxide. They might have some other chemicals in it too. That is going to be toxic to your soil micro and macroorganisms. And remember, we want them. We want that rich diversity inside of our soil. Wood ash is going to change the pH, significantly change the pH. So don't add wood ash to your compost bin, because if you change that pH too much, you're going to end up killing off all of your microbes. And finally, we've got cooked food waste. If you cooked it, do not add it to your compost bin, period. We don't want any fats inside the compost bin, no baked items inside the compost bin. They're going the biggest thing here is as it decomposes, because it's got those fats in it, it's going to smell terrible. That's where smelly compost bins come into play. Um, really and truly, your compost bin shouldn't smell bad. It should have a nice, rich, like a sweet, earthy smell to it. If you're noticing funny smells from it, like funny bad smells, then your balance of greens to browns probably is off. Okay. All right. Okay. Another question for you. Go ahead and drop it in the chat. What do you think? When is the best time to apply compost? Ooh, oh, I showed you the answer. Okay. Well, go ahead and drop it in the chat. When do you think is going to be the best time to apply compost? Is it going to be spring, summer, or fall? And if you were watching closely, you got the right answer. It's actually in the fall. Yeah. So, and the best time to apply, the very, very best time would be right after we had a killing frost. So after the frost causes all of the hostas to turn slimy, but before the ground freezes. Okay, that's going to be the best time to add your compost. But really and truly, you can add compost any time of the year. You can add, or at least spring, summer, and fall, you can add it. One thing to keep in mind, if you add it in the spring, make sure that you do it about a month before you're planting, especially if you're planting seeds, if you're going to direct sow seeds. And the reason why is fresh compost can actually inhibit germination of seeds. But as long as you get it down, like right now, right about now would be a great time for planting later on this spring. Go ahead and get your compost in now. If you add it in the summertime, that's perfect too. You can use it either like as a side dressing to plants or as a top dressing to the plants. Oh, and one other thing I wanted to share is you want to use your compost pretty soon after it's finished. You don't want to stockpile it for years, okay? So shoot for using it within about 6 months or so. That doesn't mean it goes bad if it's been a year and you haven't had a chance to spread your compost. That's not a problem at all. But you're going to lose, it is going to lose some nutrients as it sits. Okay, and I apologize. I have a few more things to get through, and I'm hoping that I will get through it all by 7. So I'm going to kind of cruise through these pretty quickly. So primary plant nutrients. The primary plant nutrients, I'm sorry, let me back up. The primary nutrients plants need from soil are nitrogen, phosphorus, and potassium. Okay. So to complete their life cycle, plants need a total of 17 nutrients, and they need them in different amounts. Some they need lots of, and some they just need a little bit of. Okay. Now, plants are going to get the majority of their nutrients, or I'm sorry, they're going to get the the majority of their carbon, their hydrogen, and their oxygen from either water or air. And that's going to make up about 94% of a plant's weight. Okay. That other 6%, those are going to come from the other 14 nutrients. And those nutrients the plant gets from the soil. And of those, the most important nutrients are going to be nitrogen, phosphorus, and potassium. Emily, I'm going to come back to your question, just so you know, I see it. I'm going to come back to your question in just a moment after I'm done here, or done with the plant nutrients. Okay, so you've got your nitrogen, your phosphorus, and your potassium. Those are your macronutrients that the plant's going to be getting from the soil. Now, some things that will influence the plant's ability to use those nutrients. Number one, how much clay and how much organic matter is in the soil. That's really going to help determine how much nutrients are there. Okay, it's really heavy clay soils, very nutrient rich. Sandy soils, not so much, but you can help that by adding the compost. Soil pH will also affect nutrient availability. Remember, we talked about the blueberries. Nutrients, the amount of some nutrients can actually affect the availability of other nutrients. Okay, so here I am thinking about Miracle-Gro. Miracle-Gro, just your regular green box Miracle-Gro, it is a analysis of 24% nitrogen, 8% phosphorus, and 16% potassium. So it's 24. The two numbers I want you to pay attention to are the first two numbers, 24, 8. It's got so much nitrogen that oftentimes if people are only fertilizing their tomatoes with Miracle-Gro, what they're going to end up with is lots and lots of leaves, beautiful thick stems, and not very much fruit. So having an abundance of a nutrient can actually make it so that way the plant doesn't use up or doesn't seek out other nutrients. So that's something to kind of keep in the back of your mind. And then also soil moisture can leach nutrients from the soil. So if it's been raining a lot, especially if you live in a very sandy area, then that might affect how much nutrients are available. All right, so let's dig into specifically the nitrogen, the phosphorus, and the potassium, because those are the big three. Those are the most important. So nitrogen is going to be responsible for rapid foliage growth, so your leaves and stems, and also that beautiful rich green color is going to come from having nice nitrogen available. One thing to keep in mind, of the big three, nitrogen is the one that is most easily leached from the soil. Next, we've got phosphorus. Phosphorus is going to promote root formation and growth, and it's also going to affect the quality of your flowers, your fruits, and your seeds. And then finally, we've got potassium. Potassium's that last of the big three, and potassium will actually help plants overcome drought stress. And it also will help with winter hardiness. Potassium, it does leach from the soil, but not very much, not as much. It doesn't fluctuate anywhere near as much as the nitrogen does. And the phosphorus doesn't leach from the soil at all. It's pretty stable in your soil. Okay, so the three numbers on fertilizer packaging is the percentage of nitrogen first, then phosphorus, and then potassium. So in the first example, we've got Bloom's bulb food. The package, so our three numbers are 5, 10, 5. So the Bloom's bulb food has 5% nitrogen, 10% phosphorus, and then 5% potassium. Whatever's left, that other, let's see, 80% of it is going to be inert chemicals or other byproducts. It's not going to be nutrients for the plants. Okay, so looking at these, I was going to have us go through and practice them, but we're out of time. So I just want to point out just so that way you can kind of go along with me. So this Harrison's Winterizer Turf Fertilizer, that one's 32% nitrogen, 0 phosphorus. And your turf fertilizers won't have phosphorus in them. Uh, at least the majority won't have phosphorus in them. Water soluble phosphorus is it's actually illegal in turf fertilizers in Wisconsin. And then this last one, 10, that's 10% potassium. Here in this Poseidon's yields, this would be more of like an organic fertilizer. This is a kelp meal. And so it is 1% nitrogen, no phosphorus, and 2% potassium. You can expect very, very low numbers in with your organic fertilizers. And then this last one here, we've got 30% nitrogen, 10% phosphorus, and then 10% potassium. So that's what those numbers mean. And depending on what you're growing, that could influence what you want to add to your soil, what you want to fertilize with. Last, I wanted to talk just real briefly about soil testing, because soil testing kind of ties together everything that we talked about today. So today we talked about soil texture. We talked about pH. We talked about adding compost and organic matter, and then also just kind of a real brief general talk about fertilizers. So your soil test is actually going to give you all of this information. And if you get your soil tested, what you'll do is you'll have a nice baseline uh, measurements of your NPK, so your nitrogen, your phosphorus, and your potassium. Actually, and I want to back up just a second here. I want to explain that. Sometimes you'll hear it called NPK, nitrogen, phosphorus, the K there for potassium. The reason why they use K is the symbol for potassium on the I am drawing a blank. The table, periodic table. Thank you. Yes, yes. So that's why you see the K there. So if you hear people talk about NPK, that's what they're talking about. So your soil test is going to tell you NPK. It's also going to tell you your soil's pH and the percentage of organic matter in your soil. Remember, you're shooting for about 5%. In this soil test, and this is an actual representative of a real soil test. In this soil test, their organic matter is 4.6, so they're pretty darn close to ideal. So it'll tell you where you're at, and depending on where you get your soil test done, it may also give some recommendations for amending your soil. If it doesn't give them recommendations for amending your soil, or you just want help interpreting what your soil test means, definitely reach out to your local extension office, and they will get you connected with somebody like me who can help you. Or if you're in Wood or Marathon County, you can always reach out to me directly and I can help you out with that. Inside the handout, I put a couple of links. One is for the UW Madison soil testing facility. And then another is a DATCAP list of just all of the soil tests that are certified within the state of Wisconsin. And just to give you an idea, I think last time I checked, a lawn and garden soil test through the UW lab costs you $15. So definitely reasonable. And like I said, it gives you an idea of where you're sitting at. So that way, before you go and add things to your soil, you'll know where you're at. So this time of year, I'll get phone calls from people that want to know, how much lime should I put on my lawn? And my first question is, well, what's your soil pH? What did the soil test say? And they'll say, well, I haven't had my soil tested. And I'll always answer back, I can't give you any sort of idea of how much lime to put on your soil, or if it's even needed, without that soil test. So before you add any amendments, the only thing I would say you can go hog wild on and not worry too much about it is compost. Compost, you're probably not going to do any harm. But anything else, you could actually do some harm by adding amendments without knowing where your baseline is. So definitely go out and get your soil tested before you make any amendments to it. All right. Well, on that note, I'm going to go ahead and stop the recording